Class, I hope you will be engaged for this lesson. I can tell if you're zoning out because I've asked your parents to install motion sensors at your desk. Best to keep our cameras on.
Sensors? Silly, Anushka. A sensor detects stuff.
Ali's correct. Let's go over a few examples. We're going to be focusing on color sensors and making a prototype. Who's up for some simple surgery with color sensors?
Me!
Your homework is to present what you learned about color sensors and surgery, but not together yet. Class dismissed. Students, present your research.
What we learned is that all humans are mistake-prone. Even the most skilled surgeons might make a mistake. Having programmed technology do the same tasks over and over again limits the chance of error. Such surgical errors can be fatal. Out of the 4,000 patients that have experienced a surgical error during operation, 59% had a temporary injury, 33% were left with a permanent one, and 6.6% of those patients passed away.
Many of these incidents occur when knives, clamps, sponges, and other materials are left inside a patient's body or when an organ is displaced. There is currently no robot-based safety check docked to a robot's hard drive. Therefore, the photoelectric sensors can also sense if an organ is missing or wrongly placed due to irregular patches of light.
Outside of the patient, and we put all the ports in the patient as if we're going to do laparoscopy with tiny small incisions. Then we attach the robotic system to those ports, and we actually are able to unscrub and sit at a 3D console right next to the patient in the room and perform the surgery right alongside the patient.
Our design plan includes photoelectric sensors, which are included within colored sensors. The transmitter of a sensor will release light of a certain color. These rays hit and deflect off of an object or surface, and those rays are picked up by the sensor camera. The first type of colored sensor illuminates red, green, and blue light on a surface. The second type of colored sensor shines a single wave light containing red, green, and blue colors. A certain intensity of all three colors will be reflected back and calculated by the sensor. From here, the programming of the sensor determines differences of an object's appearance.
Our design is a simple model using VexIQ pieces and color sensors. The robot will be placed in a random position into a pile of Vex pieces. Through programming, its sensor can determine the blue pieces from the rest of the pieces, which are gray. We have made a Tinkercad design that reflects our final design, and we will be presenting that tomorrow.
This is Torrin and Jessica, and we are here to present our STEM project prototype that we made on Tinkercad. Object is on wheels that it can move around. It has two arms on either sides, and the blue balls are the joints that help it move around. It uses the arms to help pick up specifically blue pieces. That's why we have the blue light sensor at the very top.
You may notice that this blue light sensor is hanging over the top. That's because it is not an arm itself. It does not physically get involved with the surgery, but it is always in the stable position to help where these blue pieces are. Because while the blue pieces are subject to move, we don't want our sensor to move along with it. That would make the data inaccurate. Here, you might see these two lines. A table for a patient can be put here, but since we are going to be setting our robot in a random group of Vex pieces, it would not make sense for us to be using a table currently, so we only have a rack for the table. This will not interfere with the surgery because the sensor can easily see through.